Hi everyone, in this video I'm going to explain what exactly is reentrancy attack in Solidity smart contract and how to mitigate this. So imagine there is a contract, this let's call it vulnerable vault. So this has two functionalities, so deposit and withdraw. So in this vault, which you can think of it as a bank, let's say, you can deposit some ether and you can withdraw them. So when you deposit, you are basically increasing your balance by the whatever value you send, and when you withdraw, you would imagine that the opposite should happen, right? So what is the opposite of that? The opposite of that would be this contract calling to your address with a value of your balance. Okay, so you first get the balance. If the balance is greater than 0, then only the contract should be able to send the balance to you, back to you, and then it simply calls to your address so that it can transfer back your balance, and then it resets your balance to 0. Okay, so if you don't have much knowledge about how Solidity smart contracts or smart contracts in general work, this sounds fine, but there is a loophole which an attacker can exploit, and I'll show you another contract which the attacker can use to exploit this. Okay, so this is the attacker contract. Here the attacker initializes the vault contract through the constructor, and it has this function called attack, and what it does is it initially deposits one ether, so that you are calling the deposit function here, and the balance of that attacker increases by one ether, and then it calls withdraw. So far so good, it simply calls the withdraw function. But what happens after that is that the withdraw gets called here, and then because this is making a call to the attacker's address without any function argument here, so there is no particular function of the attacker contract that is getting called. So the way Solidity works is that in those cases the fallback function gets called. Okay, so in this case this fallback function of this attacker contract will get called, and this is a very vulnerable scenario because inside that fallback scenario you can take advantage of this vulnerability. And what is the vulnerability? It is the fact that it is making the call to make the balance transfer, and then it sets the balance of the sender to be 0. What it should have done is first make the balance to 0 and then make that call. But because it is doing the call first, then what happens is that this fallback function indirectly gets called, and this fallback function, inside this fallback function, there is this call of withdraw. Okay, so it is simply calling the withdraw function. And if you think, okay, it's just calling the withdraw function, so what? It is just going to withdraw whatever it deposited, right? But in this case, what happens is that there is an infinite loop. So when it is calling, so once this call is done, then the usual mechanism is that whatever is the remaining gas, that is returned to the caller. And the way a caller receives that is if it already has a receive function. But in this case, there is no receive function in this attacker contract. So it just has only a fallback function here, no receive function. So in that case, what happens? If it can't find a receive function, it simply calls the fallback again. And the cycle continues until the contract is essentially drained. The vault contract is essentially drained. And this is how an attacker can do the reentrancy attack. Okay, so how to mitigate this? It is by simply first setting the balance to 0 and then doing the call rather than the reverse. Okay, so here is a secure vault example, and here you can see it initially sets the balance to 0 and then only it does the call, because in that case, since the state change has already happened, it will no longer be able to repeatedly do the call because its balance is already 0. Another way to guard it is simply using OpenZeppelin's reentrancy guard modifier, so that it will ensure that this sort of attack doesn't happen. Okay, and here I'm using remix, and it already gives a warning here. It's a very known attack, so it already is aware of this fact that this is a potential attack vector. So it is writing this warning: this contract has a payable fallback function, but no receive ether function. So consider adding this receive ether function. Okay, so this is a quick example of how reentrancy attack works in Solidity.